Hello. In this section we will discuss certificates usage in IPsec. So far, we discussed how two IPsec entities communicate with each other by using pre-shared keys. In pre-shared keys, the two sides needs to share the keys in advance of the IPsec communication. This is needed so that the two IPsec entities can validate each other's identities and use the pre-shared keys to create the keys that will be used for the communications. If you remember, this was the key seed which is used to get the ASCII ID A, E and D. By using certificates, pre-shared keys can be eliminated along with the burden required for the two entities to share keys in advance. Let's have a refresher first on what is PKI. Public key encryption is the concept used behind certificates and utilizes the components we already discussed before. This utilizes the public-private key pair. The whole premise behind the public-private key pair is that what gets encrypted by one key gets decrypted by the other key. So, the main issue with public-private key communication is to validate the public key of the other side, that it does indeed belong to the other side. In this scenario, entity A wants to communicate to entity B. Entity A requests entity B public key. If a man-in-the-middle attacker sends the public key instead of entity B, how does entity A validates that the public key is indeed what it received? It will utilize a third party to verify the public key. This third party is referred to as the certificate of authority. The certificate of authority is a trusted third party that entities communicate with, and trust in advance. An endpoint that wants the third party to validate would do the following. It would generate a private public key pair. It then would configure its own information and sends it in a request, along with its own public key. It would send that public key and the information that it wants validated to the certificate of authority. This information could be things like the fully qualified domain name or other information that we will discuss later. The endpoint entity would put this information in a request and send it along with the public key to the certificate of authority. The certificate of authority would get that request and validate that the information is accurate. It compiles this information along with the public key and create a hash of it. The certificate of authority then encrypts the hash with its own private key. This now becomes called a certificate. The certificate is nothing more than the information about the endpoint entity and its public key, hashed and encrypted by a trusted third party. In other words, this is referred to as digital signature. The certificate of authority now sends this information to the endpoint. Now imagine that a different endpoint wants to communicate with this entity. This endpoint trusts the certificate of authority. That means it is configured with that CA cert and the public key of that cert is trusted. The endpoint sends its certificate and public key to the initiator. The initiating endpoint runs the information in the certificate and the public key and creates a hash using the hashing algorithm specified in the certificate. The initiating endpoint decrypts the hash presented in the certificate, or the signature, using the public key of the trusted CA. Remember, this is the signature that was added to the certificate and signed by the certificate of authority, using the certificate of authority private key. What gets encrypted by the private key gets decrypted by the public key. The initiating entity has the public key, so it's able to decrypt the signature to get the hash. It's also able to run the same hash function. It compares the two hashes. If they are equal, this means the public key is genuine. Now that the initiating entity verified the public key of the recipient, it has full confidence that there is no one eavesdropping on the conversation. If it has information to communicate to the recipient and it wants to verify no one else can read it, it will encrypt this information using the public key of the responder. It will then send this encrypted communication to the recipient. No one intercepting this communication is able to read the information, since only the holder of the private key can decrypt and read it. So, now the communication is sent to the recipient can read it but no one else can. This is the whole premise of the public key encryption. We will discuss the relevance of those concepts to the IPsec in the next lecture.